Assalamu alaikum dear students. This is our next problem having been chosen from the book Modern Physics by Kenneth S. Crane. As usual, we come to its statement. The equilibrium separation of BaO, barium oxide, is 0.194 nanometer. Nano standing for 10 to power minus 9. Okay, 0.194 nanometer, and the measured electric dipole moment is 26.5 into 10 to power minus 30 coulomb meter. Calculate the fractional ionic character assuming two valence electrons. Yes, students, this problem is very similar to our previous two problems. The only difference in this problem is that here one additional thing is given which was not in previous two problems or videos. Their thing is assuming two valence electrons. Two valence electrons. It means we must have to multiply with 2. Okay, the equilibrium separation of BaO, barium oxide, is 0.194 nanometer, and the measured electric dipole moment is 26.5 into 10 to power minus 30 coulomb meter. Calculate the fractional ionic character assuming two valence electrons. Okay, dear students, here almost the procedure or methodology of solving this problem will be very similar to previous two videos, to previous two problems. However, this new thing will be dealt with in this problem, that assuming two valence electron. Okay, moreover, its helping tools, that is toolkit, will also be almost same as shown or as presented in previous two problems. Okay, so now we move to helping tools or our toolkit. Okay, helping tools, tool number 1. Dear students, we do not go in detail of this helping tool because this helping tool has been sufficiently described or discussed in previous problems. Okay, to the extent of this problem, it is enough if it is shown on screen. Okay, so it has been shown in screen. This snapshot has been taken from some book whose chapter number 26 deals with this topic, and this expression, this is equation 26.16, that is 16th definition of 16th equation of 26th chapter. Okay, helping tool number 2. In helping tool number 2, a very comprehensive table of constants, a table of physical constants has been shown. This is a very important table, and physical constants contained in this table are often used in a large number of problems of physics. Okay, now we move to tool number 3, which has been given in two alternate versions. Both these alternate versions have been discussed or described in previous videos, previous problems. So for the time being, we will skip tool number 3. Okay, so now we come to its solution. Okay, first part of solution is also quite same and has been used in previous problems. Actually, this is just a foundation to solve problems of this nature. Okay, so the portion of this solution which is being shown on screen has been used in our previous problems, and it just provides a foundation to solve problems of this nature. Okay, so we begin our solution with this frequently repeatedly used wording. We know that electric dipole moment of an ionic molecule is given as P equal to Q R EQ. Here EQ is written as a subscript of capital R, and capital R EQ is equilibrium separation. Okay, P is electric dipole moment and Q is charge, where small q is equal to small e is equal to 1.602 into 10 to power minus 19 coulomb, and Req is the equilibrium separation of the point. Okay, dear students, this value, that is q equal to this or small e equal to this, also appears in our tool, in which a large number of physical constants are included. Okay, so q is equal to small e and this is equal to this. Okay, some authors use q for charge while solving problems of relating to electric dipole moment. Okay, and some authors use the symbol small e, which is electronic charge on an electron. Okay, and Rq is the equilibrium separation of the ion. Using small q equal to 1.602 into 10 to power minus 19 coulomb, and Req, that is equilibrium separation, Req is equal to 0.194. Okay, dear students, if we go back to statement of this problem, then we will be satisfied that this quantity, that is 0.194 nanometer, is given in this statement. Okay, this first value is not given in this statement, it is given in table. Okay, while second value is given in the statement. Okay, in presence of these two values, equation number 1 becomes P equal to, yes students, here this thing needs to be explained, that here we, on one side we are saying that putting these values in equation number 1, equation number 1 becomes, while we have multiplied right side of equation number 1 with 2. Okay, this 2 is due to the reason that in this statement it is said that assuming 2 valence electrons. Okay, for a while we go back to statement. Okay, the equilibrium separation of barium oxide is 0.194. Okay, this value. Okay, this value is given, in the statement. Moreover, this value is given in the statement, 26.5 into 10 to the power minus 30 coulomb meter. Moreover, this thing is given in the statement, that assuming 2 valence electrons. Okay, assuming 2 valence electrons. Okay, anyhow, we move to solution of the problem. Using these values in equation number 1, equation number 1 becomes P is equal to 2 into this. Okay, the only difference between this among this problem or this video and our previous problems or previous videos is that Here an additional information is given that assuming two valence electrons. Okay, so in accordance with that condition, we multiply electric dipole moment with 2. Okay, P is equal to 2 into, this is the value of QRE, electronic charge on an electron. Okay, a coulomb, into 0.194 nanometer. Okay. Okay, this QRE, its value has been taken from table, while this value is given in the statement. Oh yes, in the statement. Yes. So next we will just simplify this. We have not disturbed here 2. Moreover, we have multiplied 1.602 with 0.94. Okay, multiplication of these two values, that is 1.602 and 0.194, gives rise to 0.31. Okay, yes students, here we can take more values after decimal, but I think it is enough. 2 decimal places is enough. Okay, we have not disturbed 2. We have multiplied 1.602 with 0.194, and this gives rise to this value, that is 0.31 into 10 raised to the power minus 28 coulomb meter. From where minus 28 has come, I tell you. Okay, dear students, this is 10 raised to the power minus 19 and nanometer. Nano stands for 10 raised to the power minus 9. Okay, 10 raised to the power minus 9 into 10 raised to the power minus 19 will contribute to 10 raised to the power minus 28. That is why here minus 28 coulomb meter. Okay, in the next step, we have multiplied 2 with this, and hence 0.31 becomes equal to 0.62 into 10 raised to the power minus 28 coulomb meter. Dear students, here once again, in the last step of this problem, we have adopted or followed a fashion. Okay, what I have said, in the last step we have tried to convert this 10 raised to the power minus 28 into 10 raised to the power minus 30, because it is a fashion in solution of problems of this nature. Okay, so when we will convert this 10 raised to the power minus 28 into 10 raised to the power minus 30, then 0.62 will become 62.00. Okay, any doubt? I think there should be no doubt, no confusion up to this concept. Okay, so here we have found the value of P, which is electric dipole moment. Okay, now fractional ionic character equal to measured P, measured electric dipole moment divided by electronic charge Q, QR small e, multiplied with equilibrium separation, that is REQ, where EQ is written as a subscript of capital R. Okay, so this is equal to 26.5 into 10 to the power minus 30 coulomb meter divided by 62.0 minus 30. Actually, dear students, this value, that is measured electric dipole moment, is given in the statement. Okay, this value 26.5 into 10 raised to the minus 30 coulomb meter is given in the statement, while this value we have calculated here. Okay, this value, this is the value of QRE equilibrium, QREQ. Okay, so in this place we will use this value, and in the numerator this value is given, which is included in statement. Okay, so here 10 raised to the power minus 30 coulomb meter will be cancelled out with the 10 raised to the power minus 30 coulomb meter, and hence only two numbers will appear in this expression, and resultant of this division will become equal to 0.43. Okay, we know that when fractional ionic character is obtained, then we say that this implies that 43% ionic. Okay, because percentage is multiplied with the 100, so this 0.43 will become 43.00, but here we do not write 0.00, so this is 43% ionic. Okay, 43% ionic, and this is the end of our problem, our video. Till next video, Allah Hafiz.